Hello my dear students, welcome to one more amazing session from Sri Chaitanya Academy. This is Suresh, Faculty of Chemistry. आज हम चर्चा करने वाला है alcohols, phenols, ethers, and this is a chapter which is the middle of the total organic chemistry. So this particular chapter can connect from grade 11 hydrocarbons and grade 12 haloalkanes and haloarenes, and it is going connected to the carbonyl. So when you are doing this particular chapter, you can be half done your organic chemistry. फिलहाल आप half done किया, so you are going to merge the next half of the organic chemistry. Arav, hello. So today we started the class bit early. I think you did your physics exam. How was the physics exam went? And in the CBSE NEET examination preparation series, we are into alcohols and phenols and ether. Those who are online, please like the session, share with your friends and subscribe to Sri Chaitanya Academy Infinity Lane NEET YouTube channel. And Monday से और एक नया सीरीज शुरू करने वाला है. ये सीरीज में NCERT लाइन बाय लाइन पकड़ के NCERT क्वेश्चंस करना कैसे आपको पता चलेगा, right? So in the alcohols, phenols, ethers, majority of the reactions we did it, and we do some extended reactions in today's class. So just think about the preparation of alcohols. You see, in the preparation of alcohols, so you take an alkene. When you take an alkene, you can add water and you are going to get alcohol. So this is what is called as hydration of alkene. Yeah. Ankesh Yadav, hello. Those students who are online, please like the session so that we can just see. This particular reaction you can say is a hydration of alkene. In this hydration of alkene, you have three methods. One is acid catalyzed, and another one is hydroboration and oxidation, and oxymercuration, demercuration. Remember? And we will see hydration of acid catalyzed hydration is completed in the previous classes, and we will see hydroboration oxidation reaction directly from preparation of alkene. Hydroboration oxidation. So when alkene is reacted with diborane in the presence of tetrahydrofuran as a solvent, in the presence of sodium hydroxide and hydrogen peroxide, so hydroboration is the first step. You are going to get oxidation in the next step to get the corresponding alcohol. In this corresponding alcohol, you can see here the product, it follows anti-Markovnikov addition of water. So in that you see propene is converted into propan 1-ol. This reaction is absolutely anti-Markovnikov addition. So what you see here, the basic difference between the acid catalyzed HBO and oxymercuration, demercuration. Acid catalyzed Markovnikov rule, carbocation is formed. HBO, no carbocation but anti-Markovnikov. And oxymercuration, demercuration, no carbocation but Markovnikov rule. There is no rearrangement. Okay. Ankesh Yadav, Arav Savaria. So Arav used to come to my classes on the regular basis. Let us see the details about this reaction, and this is going to be anti-Markovnikov addition offer. अगर कुछ डाउट है ना तो आप डायरेक्टली यू कैन आस्क. सो इसका मैकेनिज्म काफ़ी इंपॉर्टेंट नहीं है. सो व्हेन BH3 B2H6 is written as a BH3 when it is attacked on the alkene, you are going to get a pi complex. Di-pi complex is going to form a cyclic structure like this, concerted mechanism, 4-membered cyclic transition state is seen. This cyclic transition state is going to be oxidized by H2O2, and in this H2O2 you can see this cyclic complex is going to break, so that you are going to see anti-Markovnikov addition of water molecule takes place, so that 3 hydrogens are there in the BH3, so 3 alkylated borane is formed, and trialkyl borane that is formed in this way is going to be oxidized in the phase in the presence of sodium hydroxide and hydrogen peroxide to give rise the oxidized product according to anti-Markovnikov addition. बच्चों right? This is very important. You need not have to work on this mechanism of this reaction because it is a syn addition and it is an anti-Markovnikov addition and there is no rearrangement in this reaction. So, simplified version I can say this. And I want to say which of the following statement is incorrect about, we have to find whether it is correct or incorrect about the hydroboration and oxidation. So, let us see here, it is a syn addition of the water, so statement is correct. And also He3BO3 is formed as a byproduct according to the reaction, this is also correct. And you see it is a Markovnikov addition, galat baat hai. So simply you can go ahead with the boards as well as a NEET examination preparation bachcho, and 3 moles of alcohols are formed per 1 mole of BH3. So this is also correct and a galat cheez hai. Statement C is going to be the wrong. So the correct answer for this question is going to be the option C. Fine. Ankesh Yadav. And moving ahead, very important, preparation of alcohols using oxidizing agents KMnO4, OSO4 in the presence of NaHSO3 aqueous you can take. This is another way. So by using this you are going to get diols. By using this you are going to get diols. Fine. Yeah, moving ahead, this is a KMnO4 alkaline that is called Bayer's reagent. So when KMnO4 is added to the double bond, alkene is going to get a OH and OH on the same side. So this is a syn addition, and this reaction KMnO4 is actually pink in color. So this pink color is going to be discharged, decolorized. So it is a test for presence of a multiple bond, and this is what is called as a Bayer's reagent, and the decolorization test is called as a Bayer's test, and this test is so useful in detecting the unsaturation. So benzene has three double bonds in it, though it is not reacting with Bayer's reagent because of its delocalization of pi electron system above and below the hexagonal ring structure. So moving ahead here, you just see the reaction of OSO4 and the reaction of KMnO4 in alkaline medium is going to be the same product that you are going to get. Okay. So here OSO4 is going to be the reagent, pyridine is the solvent, NaHSO3 and H2O is an acidic hydrolysis procedural thing. So it is an oxidation process, and the preparation of, you can see here I want to say, this is your alkene, this is your alkene. When this alkene, it is treated with KMnO4 and OH minus, or you can also use OSO4 and NaHSO3 aqueous, you are going to get syn addition. What is the meaning of the syn addition here? Diol is formed at the same side of these double bond, so that it is OH and so that it is going to be OH. So the product is propylene glycol is formed. There is no kind of rearrangements are seen here. So this is a very important reaction. Talking about the carbonyl compounds, formation of alcohol can be done on the carbonyl compounds. So carbonyl compound, so C double bond O, and this is carbonyl group. It can be reduced or it can be attacked by Grignard reagent. Two methods are there. So let us see here COOH. So it is carboxylic group. If you reduce it, you are going to get an aldehyde. If you reduce it, you are going to get an alcohol. If you reduce it, it is going to get an alkane. If you oxidize alkane, you are going to get alcohol. If you oxidize alcohol, you are going to get an aldehyde. If you oxidize aldehyde, you are going to get a carboxylic acid. So this is the phenomenal. As oxygen content is decreased, reduction. As oxidation, oxygen content is increased is called as oxygen content is decreased is called as reduction. Oxygen content is increased is called as oxidation. So the same phenomena you can see here. So most reduced and most oxidized state. Carboxylic group is going to be the most oxidized form of the carbon, and alkane is going to be the most reduced form of the in the organic chemistry. So we can oxidize any alkane to get alcohol, that is the best. You can reduce carbonyl group to get an alcohol, right? So it's a phenomenal oxidation and reduction. You go and just refer your grade 10, you can understand what is an oxidation and reduction. Addition of oxygen is an oxidation, addition of hydrogen is a reduction. The same thing is seen here. Whenever oxidation is coming, just put oxygen in the square bracket on the arrow mark. Chemistry में ऐसे convention चलते रहते हैं, and also reduction चलते रहता है, hydrogen comes in this bracket. Okay, now let us see here. So tell me kind of oxidation reactions and reduction reactions. Moving ahead here, let us see. So preparation of alcohol from carbonyl compounds. You can prepare it from aldehyde, you can prepare it from ketone, you can prepare it from carboxylic acids. Ankesh Yadav, so let us talk about the preparation of alcohol from aldehyde. So this is an aldehyde, you can reduce it. You can go ahead with nickel, platinum, palladium, hydrogen. So it is called catalytic reduction. This is what is called as a catalytic reduction. You are going to get a primary alcohol. When you go ahead with reduction by using sodium borohydride or lithium aluminum hydride, you are going to get a primary alcohol. This is hydride reduction method, complex hydride reduction method. So there you are going to see reduction methods. So you can see here. So ketones can be reduced to give rise secondary alcohols. It can be used with hydrogen in the presence of palladium or sodium borohydride and lithium aluminum hydride. So want to say primary alcohols can be prepared from aldehydes and secondary alcohols are prepared from ketones. You want to go ahead with carboxylic acid, sodium borohydride. Sodium borohydride is not able to reduce carboxylic acids. That's very important. It's a weak reducing agent. It cannot reduce carboxylic acid and carboxylic acid derivative. That's very important. Carboxylic acid derivative, while the lithium aluminum hydride can reduce it. So अगर कुछ doubt है ना तो जल्दी बता सकते हैं आप. And you can also see here. So preparation carboxylic acid, it can be protonated in the with alcohol to get ester. Ester is reduced by H2PD. You are going to get a mixture of alcohols. While carboxylic acid is given here, it is reduced to give this, and you cannot use for the reduction with sodium borohydride or lithium aluminum hydride can work. That's the reason why, if you want to say, there is a famous question in C double bond O, CH3 and like this. So what if it is treated with sodium hydroxide? What could be the product? I want to know the answer from you. So this is the NCERT question. This is the NCERT question. Here it is an ester functional group, cannot be reduced, NaBH4. So it cannot be reduced, but it's a ketone alone can be reduced. But so that I don't want to touch this ester group while ketone is going to be converted into its corresponding secondary alcohol. Got it? Fine. Example here, this is the one we can say, if a mixture of alcohols are obtained closer boiling points, they can be separated by using, as we know, we can separate it by fractional distillation. Now we can see here an example. So carboxylic group is there, so acetic acid and ethanol, ethyl acetate is formed. When ethyl acetate is formed, when it is reduced by using PDH2 or NiH2, you are going to get the mixture of alcohols. Fine. And also preparation of alcohol from carbonyl. Ketone, when it is reduced to gives rise an alcohol, you are going to get a secondary alcohol. Aldehyde, when it is reduced, you are going to get a primary alcohol. And carboxylic acid, when it is reduced, you are going to get a primary alcohol. So this is the way you need to connect with what are the basic things you need to just classify the alcohols and the preparation, and that mind map you need to have. And Grignard reagent. Grignard reagent. What is Grignard reagent? Victor Grignard got Nobel Prize for this RMGX. Whenever RMGX is there, you have to look RMGX is like this. This is your Grignard reagent, right? So it is going to react with the carbonyl group. Whenever you see this carbonyl group, it is a polar group. So this will have partial negative charge and it is going to be partial positive charge. Grignard reagent is an excellent nucleophile, so that it is going to attack in this way to give rise corresponding alcohols. These corresponding alcohols, I want to say simple, Grignard reagent react with formaldehyde, gives rise simply primary alcohol. Grignard reagent react with any aldehyde other than formaldehyde, it is going to give secondary alcohol. Grignard reagent is going to react with a ketone to give rise tertiary alcohol. You can see this is a partial negative charge, is a good nucleophile, so that you are going to see the compound nucleophilic attack. When it is hydrolyzed in the acid media, you are going to get the corresponding alcohol. Are you getting or not? Those students who are online, please like the session and encourage the classes, and get ready for your upcoming NEET examination and CBS examination with a lot of josh. Please like this session, and if you have any doubt, you use the chat box and you can discuss the things with us. Any doubt? Now moving ahead, you can say aldehyde Grignard reagent is going to give rise to secondary alcohol. And when you take a ketone, when it is reacted with the Grignard reagent, you are going to get a tertiary alcohol. आपका जो क्वेश्चन आ सकते हैं CBS एग्जामिनेशन चाहे इसको NEET एग्जामिनेशन के भी, so the product will be given corresponding Grignard reagent कौन सा हो सकता. You need to have that command on the subject, so that you see this is the one. Just see the question here and the nucleophile in the given electrophilic addition reaction is. So actually here in this reaction you can say the lone pair of electron, you can say CH3 CH double bond CH2 mechanism का बारे में थोड़ा सा जानकारी करो. So it is an electrophilic addition reaction ताकि इसका CH3 CH plus and CH3, and when it is reacted with water, water has a lone pair of electron on it, it acts as a nucleophile. How simply and cleverly the question is being asked, and by the loss of proton you are going to get CH3 CH and CH3, and it is going to be OH. So that the electron pair donor is a nucleophile. So this question you have the option B as a correct answer. You all know the mechanism. You need not have to present the mechanism, but you will be asked somewhere or the somehow or the corner you are going to get a logical point. So the lone pair of electron present on the oxygen act as a nucleophile. If you have any doubts, please let us know. If you have any doubts, please let us know, bachcho. Right. So further reactions. So propan 1-ol may be prepared by the reaction of propene with, okay, propan 1-ol means you are going to get the product according to anti-Markovnikov rule. So that you see this is a propene. So you want to get propan 1-ol CH3 CH2 CH2 OH. So for that we need anti-Markovnikov addition, that is hydroboration and oxidation. My answer for this question is going to be C. Simply mention what is the answer, but you need to have to mark this as an option C. You need to have a super command on this subject that is here. बच्चों अगर कुछ doubt है ना तो पूछना. We are on this. We are giving both boards as well as NEET together. So प्लीज़ अटेंड आवर सेशन. मंडे से आपका नया सेशन शुरू और नया सीरीज शुरू करने वाला है. सो नीट line by line conversation we want to take it. So definitely 100% of the questions we are going to discuss from the NCERT based. Okay, let us see more details about this. Yeah, which of the following is not the product so of the hydration of following molecule? So when this is dehydrated you are going to get an alkene. You can get an alkene. It didn't mention whether it is a major product or a minor product. You can get a double bond here, you can get a double bond here, you can get a double bond here, right? And you can see the various options here. First it is going to give a carbocation. This carbocation can rearrange. This is another possibility of the carbocation. When if that is the one, so you have two different types of carbocation. So if that is the case, this is the product that can be formed if the carbocation is formed somewhere, right? So I want to say that is not the actual product. So B is the correct answer, which is not actually formed, right? And also let's see chemical properties of alcohols. So reactions of alcohol. So when you break the bond, alcohol is going to be a nucleophile, alcohol is going to be an acidic, alcohol is going to lose its OH group. So when it is acting as a nucleophile, this alcohol to hydrogen, the bond is going to be broken, and it is an acting as an electrophile. Alcohol alkyl group and OH bond has to be broken, right? Alcohols are versatile compounds. They can act as both nucleophile as well as an electrophile. So let us see these reaction in which they are going to be acting as an electrophile as well as a nucleophile, right? Now reactions involving the OH bond, it could be as an acidic in nature and it could be as an esterification in the way. If they are acidic in nature, acidic strength of alcohols we have to talk, and acidic strength of phenols also comes under this category, reactions of alcohols with metals, reactions of phenols with metals. When it comes to the formation of ester by carboxylic acid, by acid anhydride, by the acid chloride. So different versions of the reactions. Stay tuned in the class, I am going to show you all the reactions. Right now, acidic strength of carboxylic acid. In general, so alcohols are less acidic than water and is more acidic than phenol. Of course, acidic methyl alcohol is more acidic than alcohol. Methyl alcohol is more acidic than water and it is more acidic than other alcohol. So this is an exception case. Whenever exception case is there, you need to know that due to the electron donating group that is present in the alkyl groups attached to the OH, alcohol increases the electron density, so that alcohol का Ka value कम से कम होगा water के साथ. Okay, so acidity due to the polar OH group, you can see H plus and OH group, this group is a polar group. It can be separated easily. Now moving ahead here, acidic strength inversely proportional to electron donating group. That's the reason why primary alcohols are more acidic than secondary alcohol are more acidic than tertiary alcohol. Primary alcohol में एक ही positive inductive effect है, secondary alcohol में दो positive inductive effect है. जब आप positive inductive effect आता है ना, ये वाला more electron donating group होगा. That is the reason why we can say it is a less acidic. Fine. And as you know, which of the following compounds is the least acidic? इसका structure बना के बनाना है. So propan-1-ol primary alcohol, propan-2-ol secondary alcohol, and 2-methyl propan-2-ol tertiary alcohol, and ethanol is a primary alcohol. You can see electron donating group जहाँ पर ज़्यादा होता है इसका acidic nature कम से कम होगा. So that I want to say 2-methyl propan-2-ol CH3 and CH3 and CH3 and CH3 and it is going to be OH. It is going to be OH. So as it is a tertiary alcohol, it is going to be the least acidic. You have to just take these questions in such a way that you will understand exactly what could be the reason. समझ में आ रहा है क्या बेटा बच्चों? Fine. Waiting for your questions. Waiting for your questions. Now, so it is super important topic, acidic strength of phenols. So far, based on the acidic strength of phenols, in the NEET examination 4-5 times, the acidic strength of phenol is given. Again, phenols are more acidic than alcohols and water as well due to higher electronegativity of sp2. And it is a weak acid. Phenol is a weak acid. If you lose H plus, you are going to see the conjugate base Cb. In any case, fundamental rule in the chemistry, acidic nature is directly proportional to stability of conjugate base. So Phenol and its conjugate base, this conjugate base is more resonance stabilized. So it is going to be more acidic. I want to say here, any electron withdrawing group that is attached to the benzene ring makes it is more acidic. I mean to say here, let us say this is a phenoxide ion and the resonance structures of the phenoxide ion is stabilizing this phenoxide ion. Acidic strength is directly proportional to electron withdrawing group. Any group that can cause negative inductive effect, negative mesomeric effect can increase the acidic strength of the phenol. And electron donating group like positive inductive effect, positive H means hyperconjugation, and positive mesomeric effect decreases the acidic strength. Let us see some examples based on this. Here I want to say here the phenol with nitro group and a phenol, and this is a phenol with OCH3 group. So this is a positive mesomeric effect, this is a negative mesomeric effect. You want to see acidic strength is going to be like this, is going to be like this, right? And moving ahead, you can see arrange the following in increasing order of acidic strength. Increasing order, here you can see positive mesomeric effect and a positive inductive effect. At a meta position, you don't expect negative mesomeric effect will not go, only negative inductive effect works. In any compound at meta position, resonance do not work, and you are going to see positive, negative mesomeric effect and negative inductive effect. So what I am expected here, acidic strength, so A is greater than, C is greater than, B is greater than D. This is expected. Because A is more, inductive effect is more effective. But the thing is, there is an intramolecular hydrogen bonding. Because of this intramolecular hydrogen bonding, hydrogen जो है ना molecule के अंदर अटक गया. Adarsh, hi, how are you? So actual one comes to be C is more than, C is more than, A is more than, B is more than D. Fine. So this is a key important point that you need to know. Other shallow, that's what I want to say. Phenoxide ion. So there is intramolecular hydrogen bonding. Now you can see the phenoxide ion at meta position. These are the resonating structures. Phenoxide ion at a para position, that is the resonating structure. Now, because of this intramolecular hydrogen bonding, hydrogen that is trapped inside the molecule is not coming out. That's the reason why orthonitrophenol is expected to be less acidic as compared to the para-nitrophenol. Reasoning assertion questions also important in both CBSE as well as NEET examination. You need to have that टेंडेंसी टू अंडरस्टैंड एंड अप्लाई ड्यूरिंग द एग्जामिनेशन. बच्चों समझ में रहे क्या? अगर कुछ डाउट है ना तो जल्दी बताओ. फाइन. मूविंग अहेड हियर, resonating structures of D, leave it. Yeah, I want to say their respective acidic strength. You can say अगर acidic strength increases, Ka value increases, pKa value decreases. So this is the fundamental aspect as far as acid base reactions are concerned. So phenol pKa is 10 and nitro pK is equal to 8.3, ortho nitro 7.2 and para nitro 7.1. So this is the least pKa value, has highest acidic strength, so that as Ka increases, acidic strength increases, pKa value decreases. So I want to say among these, which of the following compounds has the most acidic nature? Come on, who is going to give the answer? This is a benzyl alcohol, not phenol. This is a phenol. This is a tertiary alcohol, and this is a secondary alcohol. This is a secondary alcohol, and this is a tertiary alcohol, and this is a phenol, and this is a alcohol, or benzyl alcohol, or primary alcohol. It is a primary class of alcohol. Among all alcohols and phenols, of course, phenol is going to be the most acidic in nature. I want to say B is the correct answer for this question. Any doubt? You can ask if you have any doubts, bacho, waiting for your questions. Moving ahead, reaction of alcohol with metals. Reaction of alcohol with metals. Alcohol, when it is reacted with active metal, you are going to get an alkoxide and hydrogen gas is liberated. So any active metals like sodium, potassium and aluminum, you are going to get alcohol. You have an acidic hydrogen over here. It gives rise sodium and hydrogen gas is eliminated, right? So that is a test for alcohol. You can see, you just take an ethanol and just put a sodium piece. You are going to get hydrogen gas bubbled into it, right? So this is a test for alcohol, acidic nature of alcohol. Even this can be given with the phenols. And also you can see ethyl alcohol, sodium metal is reacting, sodium ethoxide is formed, hydrogen gas is formed. Of course, it is with aluminum, tertiary butoxide is formed. Of course, this is aluminum tertiary butoxide is very good base. Fine. And you can see here, phenol, it is also react with an active metal, gives rise of phenoxide ion and hydrogen gas is liberated. And this phenol, when it is reacted with sodium metal. So there is a question in the NCERT, give the reactions which can prove acidic nature of phenol. Yes, phenol can react with sodium metal. Phenol can react with sodium hydroxide. Others, hope you are understanding. Now moving ahead here, carboxylic acid. So esterification, you know, carboxylic acid and ester both are going to react. Acid and alcohol going to give rise an ester. This process is called as a esterification, and the esters can be characterized by sweet smelling, sweet fruity smell. Okay, so the mechanism is given by Fischer-Speyer esterification mechanism. बच्चों वो जो mechanism है ना NCERT में दिया हुआ, and I am going to discuss it. It's very important for 2 marks. So you can see here carboxylic acid, acid anhydride and acid chloride is going to react with alcohol in the presence of an acid. So ethanol, ethanoic acid, you are going to get ethyl ethanoate, and a phenol and ethanoic acid, it is going to get a phenyl ethionate. These are all esters, right? And also you see alcohol and acidic anhydride, you are going to get an ester. Similarly, yes, it is going to give different types of ester. You have to understand, basically, my dear children, I want to say, whenever this comes now, you simply say it is a ketone, it is an ether. No, it is not a ketone in an ether. Rather, I would like to say it is going to be an ester functional group. You have to spot it out, isn't it, Adarsh? That's very good, right? And so Phenol can be reacted with acetic anhydride, okay. So you are going to get ethyl phenate, okay, and this is going to be kind of esterification mechanism. And you can see, very important, alcohol plus phenol, it can react with carboxylic acid or any acid anhydride. You are going to get an ester in the presence of an H2SO4 as a catalyst, okay. And these are the chemical properties you need to know. So during esterification, when alcohol and carboxylic acid is reacted, you are going to get an ester, right. So this ester along with water, you have to remove the water as soon as it is formed by using any dehydrating agent. Therefore, according to Le Chatelier's principle, this is a reversible reaction. Whenever you remove one of the product, the reaction is going to be more favored in the forward direction. That is very important. This is called Le Chatelier's principle, right. And esterification by acidic chloride is also. So as the sessions as going on, we discussed so many topics previously, and आगे भी ज़्यादा topics लेना है, but this is an organic chemistry which we need to connect with the previous topics as well as the forward topics. That's the reason why what happens here, acid chloride is going to give an ester. And so simple short trick I just want to say, in the esterification mechanism now, the oxygen of alcohol is retained in the ester. That is very important. The oxygen of alcohol is retained in the ester. Fine. Why pyridine is a solvent? Somebody can tell me. Why pyridine is a solvent in this reaction, bacha? So pyridine is used as a solvent. Why? Because the acid that is formed as a byproduct easily absorbed by this pyridine. Fine. Any doubt? And some reasoning questions comes under this category, bacho. Now, in the phenol, AROH means is a phenol, acid chloride, you are going to get an ester. In the same way, here HCl being neutralized by pyridine is a base. Pyridine is a base which is going to neutralize the HCl, right? But so here reactions involving ROH, you can say alcohol. We discussed this particular reaction in the preparation of alkyl halide, if you remember. Alcohol react with hydrogen halide to give race alkyl halide. Alcohol, so ethyl alcohol HCl, ethyl chloride is formed. Simply said, how do you convert ethanol to ethyl chloride? You can use anything, not only HCl here. You can use my favorite reagent SOCl2. You can use PCl3. You can use PCl5. You can use X2 in the presence of red phosphorus. Many things, zinc chloride and HCl, okay, HX in the presence of H2SO4, okay, so X is not equal to iodine, many reagents that can be used. Remember, so as the things are going on day by day, so session by session, we are increasing the number of reactions, and from Monday onwards, today we are done from our reactions, and we are going to launch new series from Monday. My dear children, just hold and do the best for the most reactions that we are going to see from the Monday onwards. NCERT line by line in this series we are going to discuss. So dear children, please like these sessions and subscribe to your this channel, and share these sessions with your friends. That can help you a lot. Okay, thank you very much. Signing off, Suresh, Faculty of Chemistry, Sri Chaitanya Academy, Infinity Learn NEET YouTube channel. Thank you.